All right, we are going to look at the first part of 4.7 tonight, the law of sines. So, before we even start in on the law of sines, we want to talk about how to properly set up our triangle because it makes a big difference. So in our triangle, we are going to have an angle A, B, and C, which is why we call it triangle ABC. And then we are also going to have side lengths that are A, B, and C. Now, what's important to notice is that my angles are all capital letters and my sides are all lowercase letters. So that's really important and we want to be consistent with that. In addition to that, where we put all of the A's, B's, and C's makes a difference as well. So if we look at our triangle and the way it's set up, we see that angle A is right here, and then side A, or little a, is directly across the triangle from angle A. That's important. It must be that way. Then I also see for my B's, I have angle B right here, and then across the triangle is side B, or little b. And then the same thing with our C's. So angle C is here, and side C is directly across the triangle from that. Okay, so now that we know how to set up our triangles, if they're not already drawn for us, we can go ahead and take a look at our law of sines and how that's going to work. So with the law of sines, we're basically setting up a proportion. Now, we have sine of big A, which is angle A, over little a, which is the side length. We have sine B over little b and sine big C over little c. Now, we will never use all three of these at the same time. We will only use two for any given situation. So what we want to do to know where to start and which two to use is we want to look first of all at what we have both the angle and the side length for. Do we have both the angle and the side for A? Do we have both the angle and the side for B? Or do we have both the angle and the side for C? And we have to have one of them, both the angle and the side. So for this first example, we're going to solve triangle ABC. And what that means when it says solve a triangle is we have to find anything that's not given to us. So if we look at the triangle we have, we know what angle A is. Great. We know what angle B is, but we do not know what angle C is. So that's one of the things that we're going to need to find is what is the measure of angle C. Now we look at our side lengths. So side A, nope, I don't know what that is, so I will have to find little a. Side B, well, that's side B. Yes, I know that one. Okay, great. And then side C, nope, I don't know that one. So I'm going to need to find little c as well. So I like to start by making a list of everything I don't know and what I'm going to have to find, because then once I know all of those answers, I know I'm done. And I know that I'm not done until I have all of those answers. Now I want to start off with the easiest thing. Since I know two of my angles, then if I think back to geometry, that third angle is super easy to find. So I know that all three angles of any triangle has to add up to 180. Therefore, if I take the two angles that I know and I add them together, so 35 plus 103 gives me 138. And then I know that with the third angle, it has to equal 180. So I do 180 minus 138. Then that's going to give me 42. Therefore, I know angle C is 42 degrees. And make sure that your angle measures have the degree symbol on it, because we need to know that those are angles and they represent degrees. Now, once I know what my missing angle is, then I'm going to move to finding my sides. And my sides is where I'm going to use my law of sines. So, let's start with what do I know both the angle and the side for? Well, I know angle B and I know side B. Therefore, that's what I want to start with. So I'm going to take sine of angle B, which is 103, and I'm going to divide it by little b, which is 20. So remember, this is little b. Then I'm going to set that equal to, well, the next thing I want to do is decide, okay, do I want to find A or C first? Well, A is the next thing in my list, so let's find A. Well, I know that little a should go on the bottom because the angles are always on top, the side lengths on the bottom. So little a should be on the bottom. Therefore, on the top, I should have sine of angle A, and angle A is 35 degrees. So now that we have this set up, we're just going to solve our proportion. So I know for a proportion, I'm going to cross multiply and divide. So the first thing that I do is I'm going to multiply by the thing I don't know. So I've got A times sine 103. So A times sine of 103 equals, and then I'm going to multiply the other way. So some of you learned this as the butterfly method. So that's going to give me 20 times sine 35. Oop. Okay, now that I've cross multiplied, I need to divide. Well, remember, I'm trying to solve for A, which means I need to get rid of sine 103. Since that's A times sine 103, I'm going to divide by sine 103. Okay, so then A is going to equal 20 times sine 35 divided by sine 103. And we need to be very careful putting this in the calculator. Although it is possible to put it all in at once, I don't recommend it. Your best bet is to type the numerator in just the way it is, 20 sine 35, hit enter, and you're going to get some horrible looking decimal, and it's okay. Once you have that decimal, then you're going to divide it by sine 103. And when you do that, you're going to get your answer. So when you type all of that in and you divide, you should get that A is approximately 11.8. Now notice in the directions, it said that we're going to round side lengths to the nearest tenth, so that's one number after the decimal place, and angle measures to the nearest degree. Okay, so great. So we have A, I can go ahead and fill that in, 11.8. And since I don't have a unit of measure, I don't need to put centimeters, inches, whatever, just 11.8 is good. Okay, now the next thing that we need to find is C. Now some of us are tempted to say, okay, well I know two side lengths, can't I just use Pythagorean theorem to find the third one? And the answer is no, because Pythagorean theorem is for right triangles only. And this triangle is not a right triangle. There is no 90-degree angle in this triangle. Therefore, Pythagorean theorem is useless here. So what we need to do is we need to go back to our law of sines, and then we need to now find C. So if I'm going to find C, that means I'm going to need to use angle C. And that's okay because we have that now. So I will never, ever, ever use a rounded answer unless I absolutely have to. So I want to try to avoid using this answer because I had to round it. And I always want to use exact answers if I can. So I'm going to avoid using that 11.8 unless I absolutely have to use it. So I started my first one when I was finding A with the angle B and little b. I'm going to do that again. So I'm going to stick to using that to begin with. So I have sine of angle B, which is 103, over little b, which is 20. But now I'm going to set it equal to the C fraction, since I'm trying to find C. So then I'm going to have sine of angle C, which is, remember we found that was 42 up here. And then I'm going to put that over little c, which I do not know. So I'm going to do the same thing I did with the other proportion. I'm going to cross multiply and divide. So the first thing I'm going to do is this way. So I have C times sine 103 equals, and then I have 20 times sine 42. Now I divide. So I'm going to divide by the sine 103 that I want to get rid of. Therefore, C is going to equal 20 sine 42 divided by sine 103. And again, I'm going to grab my calculator and I'm going to put it in. So I'm going to start by entering this into my calculator. I'm going to hit enter and get my decimal. Then I'm going to divide that answer by sine 103. And when I do, I should get that C is approximately 13.7 after you round it to the nearest tenth. So that gives me my last answer, 13.7. And so now that I have everything found that I had in my list, I know that I'm done. And so then that's my triangle all solved. So it's basically just setting up proportions, not that difficult. So the next thing that we want to look at is what we call the ambiguous case. So the ambiguous case means that it might be possible to create more than one triangle from the given information. Now we're going to begin with looking at the ambiguous case when there is either one or no solution. So it is possible with the information they give you, with the fixed angle and the fixed sides that they tell you, that it is not possible to create a triangle with those measurements. And so we're going to be able to see using our calculations when that's not possible. So what we're going to do is we're going to set out to do the law of sines just like we did in that first problem. And then along the lines, we're going to see kind of what we need to look at to determine if there is actually a triangle or not. So find all the solutions for the given triangle if possible. So that means basically solve the triangle. So anything I don't already know, I need to find it. So if there are no solutions, then we're going to say so. We're going to simply say there's no solution. Can't make a triangle from this. Again, we're going to round sides to the nearest tenth, angles to the nearest degree. So I could draw my triangle, but I don't really need to, because with law of sines, I know it's always going to be angle A over side A, angle B over side B, angle C over side C. So we need to figure out, first of all, what do we know both the angle and the side for? Well, I have side A and I have angle A, so that's where I want to start. So let's make our list of what we don't know, though. So I'm going to start with my angles. I know angle A, but I do not know angle B. I do not know angle C. That's all of my angles. And then for my side lengths, I know little a, I know little b, but I do not know little c. So those are the three things that we need to find. We're given three things, we need to find three things. So let's start with our a's, because we know sine of angle A, which is 61, over little a, which is 9, is going to equal, and we're going to set up another fraction. Now, the only other information that I know is little b. So I know that little b is going to need to go on the bottom, so that's going to be 11, which means that on the top, I need to have sine of angle b. So big A, big B, little b. All right, so we've got our proportions set up. Now we're going to go ahead and solve it. So first thing we do is cross multiply. So I'm going to have, first, I'm going to do 9 times sine b. So I have 9 times, oh, let me get rid of my circle, 9 times sine b equals, and then I multiply the other way. That's going to give me 11 times sine 61. Now, I'm going to divide. So, since I'm finding sine b, I want to get this by itself. That means I'm going to divide by the 9 in front of it. So if I divide by 9 in front of it, then I'm going to get sine of big B equals 11 times sine 61 divided by 9. Now, when I type this in the calculator, I'm going to still do kind of the same thing. I'm going to type this in, I'm going to hit enter, then I'm going to divide by 9. And I'm going to get a decimal. However, that decimal is not actually going to be my angle. So if I type that in, I do sine B, then When I type in 11 sine 61, hit enter, divide by 9, hit enter, I'm going to get 1.069 and some other stuff. Now, that's what sine b is. I need to actually find the angle. So to find the angle, if you think back to what we did in 4.1 through 3, then we know that to find the angle, we have to use inverse sine in the calculator. Now, you should have this big long decimal in your calculator right now, and we want the calculator to use that exact decimal, not a rounded version of it. So what you're going to do to tell the calculator to find sine of that big long decimal is you're going to hit second sine, because we want to use inverse, second sine, and then you're going to hit the second button and negative. Because if you look right above the negative button on your blue calculators we have in class, then right above the negative button you see answer in blue. So that's going to tell your calculator to use the last answer that you just got. So you're going to hit second sine, second negative, and then that's supposed to give you the angle. However, when you do that for this problem, you get an error. Well, that error is not because we did something wrong. It's because it is not possible to have sine of any angle equal something bigger than 1. Therefore, that error tells us that there is no solution. A triangle cannot be formed using those dimensions. So you're going to write out no solution, or you could give me a big old 0 with a slash through it. That also means no solution. So when you type it in, if you get an error, that doesn't necessarily mean you did something wrong. It might just be that there is no solution possible. Okay, so let's take a look at one that actually will work. So let's take a look at number 2. So we have two sides and an angle. So that means we need to find the other two angles. So we know angle A, we do not know angle B, we do not know angle C. Then for our sides, we know little a, we do not know little b, and we do know little c. So those are the three things in the triangle that we don't know. Those are what we need to find. So begin with, what do I know both the angle and the side for? A. So I have little a, I have angle A. So that's where we're going to start. So we're going to say sine of angle A, which is 94, is over little a, which is 15. And then the only other information we're given is little c. So that means we're going to do the c fraction. So we're going to put little c on the bottom, which is 12. And above that will have to be sine of angle c, which we don't know. All right, so we're going to solve this proportion. So we have, starting here, that's going to be 15 times sine c. And then the other way, that's going to be 12 times sine 94. And I always put the number or the variable in front of the sign. Otherwise, it kind of looks like it's all running into the sign. So like if I put the 12 back here, then it just looks weird. It looks like it might all be part of the sign, and we don't want that. So I'm going to put my 12 back in front. Okay, so now we need to divide. We did the cross multiplying, now we need to divide. So we need to get the sine c by itself, which means we want to divide by 15. So I'm going to have sine c equals 12 times sine 94, and then we're going to divide that by 15. Okay, so we're going to put that in our calculator, and then remember, we're finding an angle, which means we're going to have to do the inverse sine. So you're going to type this fraction into your calculator, and you're going to get that big old long decimal. Remember to do the numerator, hit enter, divide it by 15, hit enter, and so that's what sine c is. Now to find what the actual angle is, Then we're going to take that decimal, which should come out to approximately 0.798-ish. And then we're going to take that and we're going to do second sign, second negative, and then the calculator is going to tell us that angle C comes out to be approximately 53 degrees when rounded to the nearest degree. So we can go over and we can put that in our list of answers. We know angle C is 53 degrees. Okay, well now I know two of my angles. I know angle A and I know angle C, which means angle B is really easy to find because all I have to do is take the two angles I know. So I know that angle A is 94. I know that angle C is 53. I can add those together and I get 147. Then I can subtract that from 180. And then I get that angle B will be 33 degrees. Okay, the only thing that's left to find now is side B, or little b. So again, we're going to stick with the A's that we were given, so that's going to be our first fraction. But then our other fraction is going to have to be the B's because we're trying to find little b. So we're going to stick with the sine of angle A, which is 94, over little a, which is 15. But now we need it to equal the B fraction, not the C fraction this time. So we're going to have sine of angle B, which we just found was 33 degrees. And then that's going to go over little b, which we don't know. So we're just going to leave that as B. Now we cross multiply and divide. So I'm going to start this way with my unknown. So that's going to give me B in front times sine 94. Then multiply the other way, and we're going to have 15 times sine 33. All right, now we want B by itself, which means we need to divide by sine 94. So if I do that, B is going to equal 15 sine 33, and then divided by that sine 94 that we're trying to get rid of. Now, we're not finding an angle this time. We're finding a side length, which means I do not need to do the inverse. I'm going to simply type that fraction into my calculator, and it's going to give me the length of side B. So remember, type in the top first and hit enter. Then divide that answer by sine 94. When you do that, you should get that side length B is approximately 8.2 after we round it to the nearest tenth. So I go over here, fill that into my list of things that I needed to find, and I can see now that my list is complete. Therefore, I have my triangle and I'm done. All right, so we saw an example of when there was no solution. We saw an example of when there was only one solution. Now we want to look at when we have a triangle that gives us two solutions. So every now and then we come across measurements that will allow us to form two different triangles. So we want to make sure that we know how to find not just one triangle, but both triangles that it is possible to create. So we're going to find the two triangles for which angle A would be 43 degrees, side A would be 25, and side B would be 28. So if that's the case, then let's make our list of what we need to find. Well, we know angle A. We do not know angle B. We do not know angle C. Then for our side lengths, we know little a, we know little b, but we do not know little c. So this is like our to-do list. This is what we need to find. So we're going to start off with our law of sines just like we did before, nothing different, and just start with, okay, what do I know both the angle and the side length? A. So we're going to start with that. So we're going to do sine of angle A, which is 43 degrees, over little a, which is 25. Then we're going to have it equal. Well, the only other thing that we're given that we know is little b, which means I want to do the b fraction. So I'm going to do sine of angle b, which I don't know, over little b, which is 28. And then I'm going to solve. Now, since I don't know angle b, that means I'm solving for an angle, which means when I get done with my proportion, I'm going to have to use the inverse. So when you're finding an angle, you use inverse sine. When you are finding a side length, you use just normal sine. So we have to make sure that we can keep that straight. Okay, so cross multiplying. We're going to start with 25 times sine b equals, and then we multiply the other way, and we get 28 times sine 43. Okay, then to get that sine b by itself, we divide by 25. So sine b equals 28 times sine 43, but then divided by 25. Now we're going to put that in our calculator, so type in the numerator, hit enter, divide it by 25, and you are going to find that sine b equals approximately 0.764-ish, and then your decimal will go on. Now to find the angle, we're going to do inverse sine, and then second negative, so second sine, second negative, and it's going to tell you that angle B is approximately 50 degrees after it's rounded. So we have angle B, great. That means it's super easy now to find angle C. So take the two angles we know, add them together, subtract it from 180, and then you're going to find that angle C should be 87 degrees. Okay, now that we have our missing two angles, we can focus on finding our missing side C. So we're going to stick with the A's again because we were given both of those. So we're going to have sine of 43, angle A, over little a, which is 25. But now we're going to set up the C fraction. Well, we now know angle C because we found it. Angle C was 87 degrees. And then we're going to do divided by little c, which we don't know. So then we're going to cross multiply and divide. So we do c times sine 43 equals 25 times sine 87. Then we divide. We want c by itself, which means we have to divide by sine 43. So we have 25 times sine 87 divided by sine 43. And now, this is not an angle, it's a side length, so you're just going to type it in and be done. So type in the numerator, hit enter, divide by sine 43, hit enter, and we should find that little c is, after rounding, 36.6. Okay, so that gives us our full triangle. Now, the only thing is, though, I'm supposed to have two triangles. So I want to, now that I have my first triangle completed, I want to focus on my second triangle. So for my second triangle, I am going to take the first angle I found in the beginning. So the first angle that I found was angle B. So this one. And I want to find the supplement of angle B. And if we think back to our geometry, long time ago, a supplement means two angles that add up to 180. So if angle B is 50, then its supplement would be 130 because 50 and 130 add together to give us 180. So our supplement is going to be the new angle B for our second triangle. So we're still having to find angle B, angle C, and little c, but our numbers are going to be different because it's another triangle that uses these same measurements. So we're going to take the first angle we found, which was angle B, here, and we're going to find the supplement of that. So the supplement of angle B is 130. That's going to be the angle measure for angle B in our second triangle. So find the supplement, and that will become that same angle in the second triangle. Okay, now once we know what that angle B is for the second triangle, I can do the exact same thing that I did for the first triangle. So once I get that supplement, that's my new angle B, and I can basically forget everything that happened above that squiggly line and just do my triangle again. So I know, again, angle A and little a, so I'm going to go ahead and set those up in my proportion. So sine of angle A, which is 43, over little a, which was 25. Ooh, and actually before I do that, I could find angle C, because I know angle A was 43 degrees. I know that the new angle B is 130. So if I take those, and I have 43 plus 130, that gives me 173. And then if all three angles need to add up to 180, then 180 minus 173 means that angle C is very tiny. It's only going to be 7 degrees. So this is going to be a very long, skinny triangle. Okay, so now that we have angle C, let's go back to here. We're going to finish solving our triangle. So we've got our A's set up. Now, let's go ahead and we can find side, oh no, we know B. So the only other information we know is B, so we're going to set up our B fraction. So we're going to do sine of angle B. Wait a minute, nope, oh, nope, I'm wrong. The only thing we don't know now is C. So we want to set up the C fraction. I'm so sorry. So set up the C fraction. We know sine of angle C, which is 7 degrees, over little c. So then cross multiply and divide. So we have C times sine 43 equals 25 times sine 7. So then we're going to divide by sine 43 to get C by itself. So 25 times sine 7 divided by sine of 43. And so type that in your calculator. You do not need to do the inverse because you're not finding an angle. So type in 25 sine 7, hit enter, then divide that by sine 43, and you should find that our new little c is approximately 4.5. So we fill that in and we say, okay, we know everything. So I now know what all the missing things would be for my first possible triangle and also for my second possible triangle. Alrighty, so that is a case where we have two triangles possible given the same set of information. Now I want to do one more of those with you because I know that one's a little bit iffy. So we're going to take a look at a second one and kind of try to cement everything. So we're going to find two triangles where angle A is 38 degrees, little a, side A, is 8, and little b is 10. So we're going to have two triangles. So we're going to start with our first triangle. And we know that what we need to find is angle B. We need angle C. And then for our side lengths, the only one we don't know is little c. So now that's what we need to find. That's our to-do list. So we're going to start with, what do we know both of? We know both angle A and little a. So that's our first fraction. We're going to do sine of angle A, which is 38, over little a, which is 8. Then the only other information that I've been given is little b, which means our second fraction has to be the b fraction. So it's going to be sine of angle B over little b, which is 10. So we're going to cross multiply and divide. So I'm going to start with my unknown. So 8 times sine B equals, and then go the other way, 10 times sine 38. All right, now we divide. So since we want sine B by itself, we're going to divide by 8. So we have sine B equals 10 times sine 38 divided by 8. Now you're going to type this into your calculator. Remember, type the numerator in, hit enter, then divide by 8 and hit enter. But this time you're finding an angle. So once I get what sine B is, which that comes out to be approximately 0.7696 and some other stuff. Then once you have that, you're going to take your calculator, you're going to hit second sine, second negative sign, and then it's going to give you what angle B is. So angle B is going to be approximately 50 degrees. Now, I know on the last problem, our angle B came out to be 50 degrees. That is just a coincidence. It does not always happen. So our angle B is 50 degrees. So then we can take the angle A we were given, the angle B that we just found, and we can find out what angle C would be. So if I take those, and I'm going to do 38 plus 50, that gives me 88. Then I'm going to take 180. I'm going to subtract my 88. And then that's going to give me 92. So I've got that angle C is 92 degrees. Great. The only thing I have left to find is little c. So I'm going to take my a fraction again, but then instead of the b fraction, I'm going to set it equal to the c fraction. So we have, stick with our a fraction, sine 38 over 8. And now to set up my c fraction, I'm going to do sine of angle C, which we found that angle C was 92 degrees. And we're going to put it over little c, which is what we don't know. So cross multiply and divide again. So I'm going to start here with my unknown, c times sine 38. And then that's going to equal 8 times sine 92. Now since I want to find c, I'm going to divide by sine 38. So c equals 8 times sine 92 divided by sine 38. So we're not finding an angle, so you're just going to type that fraction in, and that will be your side C. So 8 times sine 92, hit enter, divide that by sine 38, hit enter, and I get 12 point, and then it comes out to be 986, but we need to round side lengths to the nearest tenth. Well, remember, tenths place is one number after the decimal. Well, that 8 causes the 9 to round up, and then since the 9 rounds up to a 10, that means it also rounds up the 12 to a 13. So this is actually just 13. However, we want to make sure that we are being very clear that that is a rounded answer. It does not come out to be exactly 13. So when you round, if it rounds to a nice normal number, then what I want you to put is, I want you to put 13.0, because that tells me that it rounded to 13. It did not come out to be exactly 13. Okay, now that's our first triangle. We now need to work on the second triangle. So remember, for our second triangle, we are going to take the first angle we found, which was 50. We need to do the supplement of that. So for our second triangle, we are still finding angle B, angle C, and little c. So, but they're all going to be different. So for my second triangle, take the first angle you found, which in this case was angle B. You are going to find the supplement of that. So what plus 50 gives you 180? 130. So again, yes, it is a coincidence that this comes out the same as the previous problem. It is not always that way. So the supplement of 50 is 130. That means that is our angle B for the second triangle. Then once I have that, then I'm going to simply use this information I was given and this new angle B that I found, and I'm going to finish solving my triangle. So then, knowing that angle A is 38 degrees and my new angle B is 130 degrees, then I'm going to take that angle A plus my new angle B. I'm going to add that together, which is 168. Then I'm going to subtract that 168 from 180, because all angles add up to 180, and that gives us 12. So angle C in the second triangle is 12 degrees. Now the only thing that's left for us to find is little c. So again, we're going to stick with, we know both A's, so let's start there. We have sine of angle A, which is 38, over little a, which is 8. And now since I want to find c, I'm going to set up my c fraction. So I have sine of angle c, which remember in the second triangle, angle c is 12. So sine of 12 divided by little c, which we don't know. So cross multiply and divide. So c times sine 38 equals 8 times sine 12. Then we divide by sine 38 to get the c by itself. So c equals 8 times sine 12 divided by sine 38. And then remember, type in the numerator, hit enter, divide by sine 38, hit enter, and then we're going to round our answer to the nearest tenth. And this comes out to be 2.701 blah, blah, blah. And so rounded to the nearest tenth, that would come out to just be about 2.7. So 2.7, and we have two triangles for the same set of information. There we go. So if you are asked to find two triangles, then that's how you do it. So you're going to solve the first one just like normal, and then you're going to take the first angle you found, find the supplement of that angle, so 180 minus whatever that angle is, and then that supplement is going to be that same angle, but in the second triangle. Okay, so hopefully that second one made a little bit more sense than the first one. So we have one last thing left to do, which looks kind of ugly, but it's actually really, really easy. So we need to be able to find the area of a triangle given side, angle, side. So we have to think back to geometry. What does side, angle, side mean? So notice that the A is sandwiched in between two S's. That means that you are given two side lengths and you are given the angle in between them. So the A is sandwiched between the S's, which means the angle that you know is sandwiched between the two sides that you know. Okay, so basically, if we think about our triangle, then if those are the things we know, then let's say this is A, B, and C. That means this would be little a, little b, and little c. So that tells me that the things that I am given will all have different letters. So that's when you know that you can do the area using this. If the angle and the two sides that you're given all have different letters. Now we have three formulas, but they're all really basically the same thing. So you have 1/2 times side B times side C times sine of angle A. Notice they all have different letters. That means that A would be sandwiched between B and C, just like we have here. The other two are the exact same thing, just a different combination. So that would be, the next one would be, we know angle B. So, hang on. We know angle B, and we know side C and side A. Well, notice, sandwiched between, all different letters. Same thing. Then, we can also, the next one, we have angle C, that would be here, and side A and side B. Again, the angle is sandwiched between the two sides, and notice they all have different letters. So it's all exactly the same formula. It just depends on which angles and sides you're given. So we're going to make this real easy. You're just going to do 1/2 times the two sides you're given times sine of the angle you're given. That's it. Now you do have to make sure though that the information you're given, the angle you know, is sandwiched between the sides that you know. And it is. Therefore, we're going to go ahead and do our formula. So we have that A is going to equal 1/2, or you can do that as 0.5, times the two sides that were given, which are 10 and 7, times sine of the angle we're given, which is 108. And so at this point, you literally are just going to type that in your calculator. So in your calculator, I would probably do 0.5 times 10 times 7 times sine 108. And then you are going to get your answer out of that. And it comes out to be, looks like approximately 33. And then we're rounding to the nearest tenth. So that's just going to be 0.3. Now be careful, because since they have given us a unit of measure, we have to have that same unit of measure. But since this is area, it's going to be centimeters squared. And so that is it for law of sines. So not as bad as it looks. There's just a few little things that you need to be careful of and keep straight. So tomorrow we will take a look at law of cosines, but for today you're going to do the first 4.7 assignment on your assignment sheet, which is on the back of your calendar, or if you didn't get a calendar in class, then it will be on Canvas. It'll be in the very first module. There is a link for calendar and assignment list. So you'll look at that and you'll be able to get your assignments off of there. Alrighty.